Once we've cut up our material into some of the core material, this select material will then be glued. We want to make sure we cover every surface. Then it's going to be put into our big clamp, held for an extended period of time. This is clamped at about 60-65 pounds PSI. It equates to roughly about 2,000 pounds of pressure. He's gluing up some of the bottom rails or top rails at this time. He's able to click it into place. Then what he'll do is he'll use the ratchet, and that'll draw everything down to the proper strength that it needs to be. Once that bottom's out, we know we've got the right strength on there. Now it'll sit in there until it dries to the correct moisture content, and then we'll be able to machine it later on. We're going to get it as close as we can to up and down uniformity. We're going to true that up at a later stage in the game by sanding it. So at this point, this is going to sit here, glue up, and then, like I said, dry down to the proper moisture content. We'll take it out of that machine when it's done. We'll bring it over here to the racks, and you'll notice we've got the oak core here, and on the edges, this is actually going to be for a walnut door. These are walnut edges. So you have the walnut edges ready to go, and then your faces top and bottom will go on this door to make a walnut door. Again, this is a rough stage of the game, and our next step after this dries down and sets correctly is you can follow me over and I'll show you the sander that will take it through. Here's some more material. This one has a mahogany edge on it, or a sapele edge, with your oak core. Again, you got your 2 1/4 door. This will be going through the sander. We'll go ahead and follow it through. We'll walk through on the other side of it, follow it out. So we'll buzz that through the sander. And that will come out this end. It's a top sander, so the top piece will be ready. Take the machine, or take the pieces back through, flip them over so that then you can do what was the bottom, now becomes the top. Buzz them through so that they are at the proper thickness you're looking for. We only run a rough sand on this stage of it because we don't want it to be too smooth. We want to give a good adhesion area for the wood. So you're running a rough, coarse sandpaper at this point in time. The next stage of the game will be putting the faces on. What we have here is a resaw machine where some of the select lumber that we had picked very early on in this stage of the process, these are going to become the face boards or the face pieces of the door. We're resawing it to the proper thickness, roughly about 7/30 seconds. We have to move it at a slow speed for 2 reasons. One is we don't want to cause the blade to break, and the other one is if you don't run it at the proper speed, what can happen is your blade can move up and down too much and give you too much of a variance, and that's something we don't want. We're looking for accuracy. Now that the faces have been cut, they're married up with some of the core material, as well as this interleavient paper to help control any kind of the moisture. They're going to be put on this cart. They're going to be brought over here to where Bruce is rolling out the core. Going to put the vapor barrier in between there. Roll another layer of the glue. He wants to make sure he gets constant coverage. And then he'll put the face board on. This is just one side. The other one he's already got put on. And then he'll take this and he'll put this right in the press. We're going to put this in a flat press. And that's going to be a Sapele leg for a door, for a stile. Bruce is actually the first employee that we had here in 1989. He was hired 1 week after the company was incorporated, and he's still here with us. It's been 25 years. I'm going to bring that press up. Again, we said this is a flat press, so it's steel top, steel bottom. We're going to press that with quite a few 100 pounds. You see the glue squeeze out. That's going to remain in there for the proper amount of time, and it not only makes sure that that's glued straight, but it also gives us good quality. This same area of the company, we not only make up the tops and the bottoms pieces for the stiles and rails, we also make up our panels. One of the things that we do is we'll take MDF and shape it into the panel shape, and then we'll press a face on that, or a piece of material that we're looking for. One that'll match the door. So what he's doing now is he's prepping the material to be able to put onto the MDF, and that's a piece of Sapele skin. Size that out, press that down, and then that'll sit for a little bit to tack up. Once that panel material is prepped up, it's going to be brought over here to a bladder press. You'll notice if we hit that, it's got a hot oil in there. This is actually going to press at about 2 tons, but he's putting that panel face down with that material on there. He's going to close it up, and what that's going to do is press that face right onto that panel. Maybe I can clean the glass a little for you. That'll literally bury that right into the oil, right into the bladder. Your end piece, your end result will look like this. This is one we've done a little earlier. So it's taken and formed that piece of wood around that core. Here's a pine one, here's a Sapele. Nice ribbon cut Sapele. Over here is an example of how we would do a V-groove material. We would take removed material that is MDF, put in Sapele, then we would press the face over top of it. Okay, what this does is it makes a very, very stable panel. Then we come back by putting it on the CNC router, and we can cut right through those areas where we put the material, these areas here, and it'll give you solid wood all the way in and out of those V-grooves, but it'll give you the stability of the MDF. One of the processes we do here at Signature Door in our custom department is custom grill work, and I'd like you to take a look at the door we have here. This has been sized up and ready to have the tape applied so that we can take a solid sheet of glass and then put your mullion bars over top of it. I'd like to show you how that piece of equipment works. We have 2 heads that are inside there, and that'll pop up, cut all the way through that piece of material. And what it's doing is it's notching basically a male and a female part. So he's producing the one part now. And then by flipping it, we'll produce the other half. So you see how we had that in that direction and it cut that notch out. If he put it this way, it would have cut the notch in the other direction. The neat part about that is we bring it over to the table here. Gonna lay that piece down. This piece will come over top of it, and those two will literally snap down into place. It's a very tight fit, but it doesn't get any cleaner. What we're doing here is we're gluing up some laminates, some wood laminates. He's got aspen, and he will glue up a certain amount of aspen to give us a certain thickness, and then we'll put on another face of whatever we might be producing, whether it be walnut, mahogany, sapele, cherry, beech, you name it. We'll glue these up, and these are going to be a shape. So we'll put the glue on these, we'll stack these, and then this will actually get bent around a form. This is a large form that you see here. And then over behind me is one where we've already bent it. It's already been held into place. And you can see the individual pieces. And everything is glued, held into place. Once that sets for the appropriate amount of time, we'll be able to pop that out. And what that will look like is over here. Now this is one that's been bent and it's setting in the proper size. Again, you see all the little laminates and all the little pieces in there. This is hard. It's not going to go anywhere. So once we put that shape in there, the particular profile the customer's looking for, it's going to be accurate. As long as we've made it accurate, it's going to be accurate on job site. Some of the different profiles in that we can do, really limited to what your imagination is. I'd like to show you how some of the cutter heads work. This particular piece of casing, just a small beaded casing. This would have two sets of cutters, making the outside profile, and this back profile would have the relief for any kind of step in the wall, maybe the drywall to the jamb. And really your imagination is to whatever you can make with a shape. We can make these cutters here. Some of the cutters you can bring in. You could literally draw a line on a squiggle on a piece of paper, and we can produce that. So you can see how that knife is used to produce each one of those pieces. I'm sorry, backwards on that one. So you can do pretty much any kind of profile, including stacking them, multiple profiles. This piece of equipment is a 5-head molder. A piece that just come into the machine first went through head number 1, which is actually a bottom head. Went through head number 2, which is a side head, putting the profile on there. Then comes into head number 3, which does the other side. So the side I'm shining the light on right there. It then comes down through to head number 4, which is your top head. That'll do your top profile on this particular piece. And then back again to head number 5, which will put any additional kerfs or anything like that that may be needed on a particular product. So it went in as a square 4-sided piece of material. It's coming out with jam. This is a pretty basic one. It's actually 6-sided. So it shaped the top pieces on there, cleaned off the bottom, the sides, rounded over everything. This is very basic for what this piece of machinery is capable of doing. Give you an idea, these are just some of the cutter heads that are available, and just all along the wall back into this case we have quite a few different heads with different shapes. They can be set up onto the machine and run inside, outsides, curves, you name it. This is all for straight length molding. We'll show you in a couple seconds later some equipment that will actually do curves. We literally have hundreds upon hundreds of knives of different profiles on hand. Some of the different bearings and drive wheels. Pretty sophisticated piece of equipment. Jimmy's going to run this piece of equipment. This is a single head overhead molder. He's running an arched brick mold to be your typical 180 profile. Notice he's keeping his hands as far away from that machine as he can. Letting the machine do the work, also letting the machine do the guiding. He's just simply pushing down in place. This would be for a round top door. Could also be for a round top transom. This profile will then get touched up with a piece of sandpaper. Again, if you look real close, you can see all the individual pieces. When you stain that though, you really won't pick up any of that. It's a much more stable piece than trying to do it in one solid sheet. And Jimmy's been with us here for 15 years. Here we have what we call our big pegboard wall. It's a homemade wall with sheets of plywood and OSB. And we put the different pegs into different positions we might need. And what we're doing is we're holding these pieces that are laminated so that they can dry down to the proper moisture content. We introduce a lot of moisture to it when you're putting the glues to it, but this holds it in place, allows you to wait to the proper time when you can machine it. Continuing to follow over here, this is one of our custom areas. Jimmy just ran a piece that he'll use later on for this particular unit. This is a double door round top unit that you can see here. Good 10-foot tall door unit. It's not uncommon at all for you to come through here pretty much any day of the week and see 10-foot tall door units being made. This one is being made in Sapele, and he's going to do a lot of the pre-fitting in that here. We did show you as well the different drawings and things like that at the very beginning of the show. You'll notice everywhere you go, there's drawings all over the place, everybody following the templates. So this door here is a Gothic top. And if you pan back, you can see how well this bent piece of jamb is actually following that line. It needs to be very, very, very accurate because the doors are going to be built with this particular shoulder shape in it as well. So there's very little room for error. Over here we have a transom, a very large transom. This will be going over a double door with side lights. Right now it's prepped up and ready, waiting for 1-inch insulated glass, which will be the transom. We're doing at this point in time is putting face pieces through. This happens to be walnut. This is going through the sander to be rough sanded on both sides so that we get a good glue adhesion when we're putting it on the face. On the back side here we have two things to show you. One would be some of the belts. The other is, this is a product we do as well, a bifold door system. We can actually manufacture this up to 52 feet wide by 13 feet tall. It can do up to 16 doors. So you'd have 8 doors on one chain, 8 doors on another. I'd like to show you one of the chains. This is a multiple door system. It works very, very simply. You can have it operate as one door. I come inside and I'm going to pop just the head and the foot pins. At that point, that whole unit's free and I can slide it out of the way. You can see how easy that operates and stacks. I really don't have to use much force at all. At this point, this is a big wide open area that you could go out to your pool, you could go out to a patio area. You can get these manufactured with a hurricane rating as well. They seal 50 times better than a sliding patio door, so they're pretty efficient. This is one of our 3-head 5-axis routers. You see it setting into place. We're going to make a couple parts here. It can grab different tools, clean things up. On this particular one, we've got the saw blade, but it's capable of pretty much doing anything. This piece of machinery has more movement than your arm, wrist, and shoulder combined. You could basically take a stump, set it down on there, and that thing could carve you a basketball, including the dimples. It's very, very impressive. It'll operate at 100 thousandths of an inch. You'll see it's grabbing another tool that it needs. You can put any tool head on there that you might want. It has the hogging bits, it has the router bits, it has drill bits, you can even put sanding pieces on there if you wanted, different shaper heads. What we're doing here is we're truing this piece of product up that we've glued up, making sure that it is square so that when we glue it up on the door, we don't have a door that's not correct and not true on plane. Has a 5-axis capability. It can grab a head and do a 3-axis capability. And then it also has a third head that'll give you what they call the drilling capability. So it's actually just a drill head. This will do anything we need to machine a part. Goes around, it trues it up. It'll then go grab the boring bits that it needs so that it can make the holes for the dowels so that we can dowel the door together. Again, it just goes and grabs the particular part it needs, brings it out, zeroes it out so that it's accurate. Here's the dowel boring bit coming down into place. It's a good shot to be able to see how it operates. If you notice, it doesn't go straight in, it actually oscillates. We're using a 5/8 bore, and we're using a 1/2 inch bit to get a 5/8 bore. By oscillating like that, we're getting a perfect 5/8 hole every time. If you try to drill a 5/8 hole with a 5/8 bit, you'll get too much deflection and the hole will actually be oblong and not a true 5/8. Once the parts and pieces are made up and the dowel holes are drilled, everything's correct, everything's going to be glued up properly, put into place. One of the things I said earlier about the dowel hole, you'll notice how tight they're going in there. There's absolutely no slop in that. That's a proper dowel hole. That's the way it should be done. Just going to get everything glued up, and we're going to draw it up, clamp it into place, and that'll sit for a period of time before we run that through the sander. So we'll go ahead and glue this up here in a second. You notice the dowels also have a groove on them. That allows for a little bit of a glue area. Also, when you're pulling them together, it allows for a glue area to squash out. You don't want to create an air pocket in there. Get it close and then draw it up with the clamps. We use the bar clamps versus a pipe clamp because with a bar clamp you get a lot better strength and a lot straighter hold. More accurate. You can see when you draw it down you will get a little bit of deflection, but you get a lot less with a bar clamp than you would a pipe clamp. Next stage is to set this aside, let it dry. We'll come back a couple days later and sand it. Now that the door parts have been made up and that we've glued them up and they've stood and spent the proper time drying, we're now ready to sand that part. And I want to take a notice to this particular piece. We're taking through the sander now. This is 2 1/4 inches thick. And you know, earlier we had showed you how the jamb had to wrap around. This is one of the doors for that particular setup. So we'll go ahead and sand this now. And when we sand it, I'd like you to actually point out, we have sealed the top and the bottom already with a formulation that we've come up with that's been very good with keeping any kind of moisture out of the top and the bottom of the doors. We do that before we sand because now we're going to face sand this so that if there's anything that lipped over top, we can now remove that. So we'll show you that sanding process right now. I'm going to go ahead and pop the sander open. On the right, you'll see belt number 1, that's a coarse belt. Belt number 2 steps down to a little bit finer grit. Belt number 1's a steel belt. Belt number 2 is actually a bladder in there. Steps down to belt number 3, which is finer yet. You'll notice that belt slowly moves back and forth, side to side on the machine. That's so you don't get a constant wear point on the same point. The very last set it goes through is a set of orbitals. That's going to remove any lines that may have happened during the first 3 passes. When that comes out, it's going to be inspected underneath the light. That's ready for any kind of stain, paint, whatever you might want to do with it. That's as smooth as can be. You won't find anywhere that there's a step. It's absolutely gorgeous. The next step for this would actually be to take it over to the door department where we're going to put panels and or glass, whatever might be into it. Before we do that though, I'd like to show you some more of the layups. On our second CNC router, one of the things we're doing was we're making parts and pieces for that door we just saw sanded. This is going to be some molding. And I'd like you to take a look, if you can peek in this back corner. This is a template for this, and you can see how close that molding is following that line. We know that's correct whenever it matches that template. Some of the different things that we can produce with these machines, different oval pieces of material, and I would like to point out that while we have a seam here, if I flip that over, you've got a seam back here and back here. Our moldings do not have a break all the way through, so that will never open up. The machine behind us, we'll see them finishing up this particular piece of molding. This is a 3-axis CNC router. It has an 8-head turret. It's currently cutting with a saw blade. It's pretty much run the profile on there. We're just finishing up the process on this. When it's done, I want to show you, we actually have a laser mounted to the ceiling that'll project that part. See the laser there? He'll then take that part and he knows where to go ahead and put the next one on. So he's going to snap that part out. What he did right there was release the vacuum. Everything is held in place with a vacuum, and then it'll just clean up the little bit of a strip on the back. When it comes time to put the next part down, run the next piece, he'll know exactly where to lay that. He'll be able to take that piece and put it really anywhere within that, as long as that laser shape is being projected onto the part. We know exactly where that piece is going to cut. Another piece of equipment we had, third CNC router. This is actually a sister, we call it, to the other big router we have. We're cutting and machining for the locks. It'll do the edge bores, it'll do the face bores. Go out and grab the different tooling again that it needs. This one also holds 48 different tools available to it. This is doing an edge bore. This particular lock is a multi-point lock, so it gets a bead of steel all the way up the edge of the door. These things are within 100,000ths of an inch. It's pretty impressive. It'll drill everything you need. It'll drill the screw holes. It'll drill the pockets you need for the locks. While we're also doing the lock boring, we also do the other side where we do the hinges as well. So we do any and all boring we need on this particular piece of equipment. This particular machine, we have a tiger stop on, a saw stop. You can just simply type in the numbers that you're looking for, the size you're looking for, it'll go out there and find it. We don't have to worry about one employee's tape measure being off a little different than another's. Everybody's is the same thing when you're using the same equipment. What we're doing now is we're cutting some panel molding. This is a double lip molding, and we do it for a reason, which we'll show you here in a second. But he's going to take it and he's going to cut 4 pieces. And then we're going to shoot them behind with a fastener that literally will make that up like a picture frame. So we've got our 4 pieces. He's going to bring it over and it's going to shoot from underside. And you may hear it hit multiple times because it's doing multiple staples. But it's drawing that together and that won't open up when it's out in the field. Now if we look at the back side of that, you see the staples where it's holding it in. You also see the accuracy of the miters. Now the next step will be these grooves will get filled in with a down 995 silicone, and this groove will be where the panel will go. This groove will actually be where it would lay in the door. These are actually the staples. They come in different lengths, and you can actually, this machine is accurate enough you can actually stack them in there. One of the things you'll notice is that we like to make up our panels out of MDF material and then put a face on it. The reason we do that is it's much more stable than a solid piece of wood. And if you notice on any wood door, the panel itself is actually the thinnest area, and that's where you're going to get your most movement. So we like to make it out of MDF because it's very, very stable. Now, what he's doing here is he's attaching that panel into that molding, and then that molding will be placed into the opening on a door. It takes the panel and keeps it off of the stiles and rails of the door, so that way if any panel movement would happen, you're not going to create pressure on that door, causing that door to bow, twist, warp, or possibly even blow apart. I want to show you how important that is. Again, with that being the smallest portion of or the thinnest area of the door, that's going to be your weakest area. That's the area where you're going to get your most movement. The other thing we like to do is we like to separate it front from back. So we do not have the 2 panels together. Take my driver's license there, you'll see that we have a full gap. I can also take, you'll see it almost disappears in there. You've got that much room for any kind of expansion and contraction. It also allows us to do one species on one side, and I can do another species on the other side of the door, and I don't have to worry about one side fighting the other if I have a hardwood and a softwood. But our biggest reason for doing this is you have an inside panel to the door. You also have an outside panel to the door on the reverse side. Why do we do that? It's pretty simple. If you look at the forces that are really playing with a wood door or really any exterior product, you'll notice that the outside of your house, particularly in the Pennsylvania area, will be from anywhere from 0 to 100 degrees outside in a 6-month time period. What happens on the inside of your home? The inside of your home is pretty much 65 to 70 degrees year-round, pretty much same relative humidity. But again, the outside, constant humidity changes, constant weather changes. You've got the heat, you've got the cold. So the only thing constant about the outside is change. So if we engineer our product so that the outside panel can move as it needs to and the inside panel can move as it's required to, you have a much more stable product. What this actually does as well is it causes the door to to cost a little more, because instead of putting 6 panels in a 6-panel door, I'm actually putting 12 panels in a 6-panel door. We also have what we call our signature seal of approval. It's a coin. It'll actually go into jam. I'll show you one a little bit later. It also has an individualized number. It says signature door, made in Altoona, Pennsylvania. If it's non-impact, it'll have this coin. If it's impact, it'll actually have a hurricane symbol to it. This is an individualized serial number. You can come to me 10 years from now. If you read me that serial number, I'll know exactly what we did for your door. I'll know exactly the color of it, the material of the wood. I'll know what locks we may have put into it. I'll know if it's hurricane rated or not. I'll know the depth of the door, thickness of the door. If it had arches, I'm able to take and remake a door to the same arch, say if something would get damaged in a storm. It really ties it back and makes it one-of-a-kind product. We're the only company out there that's actually doing that in that fashion. Right now, he's putting in the Down 995 silicone. This is a structural silicone. It's part of the hurricane ratings that we've achieved. But we use it for everything for a couple reasons. One is it is a structural silicone. It makes the door stronger. But then also it gives a black back to whenever you put the piece of glass in. You'll notice that when he puts it in with the crane here, you'll get what we call squeeze out. There's too much material in there whenever we put the glass down into that bed of the wet material. And we do that intentionally. There's too much in there intentionally. The crane helps save on the back. It also allows you the accuracy. He's putting this piece of glass, you know, on a 10-foot tall door. And it's not uncommon for us to put pieces of glass in. They're about 9 feet tall into 10 feet tall doors, so you need the accuracy. And you can see when that squeezes out, when you push on that, you don't see any of the wood there anymore. That's good, because when you look at it from the reverse side, you won't see any of the wood in behind, or where you might see paint or stain coming and going. You don't get that with our product. The next thing he's going to do is he's going to drop the stops in place. Everything will be cleaned up real nice, and he'll just shoot that in. What we have here is a round top door that has the grill on the face. This is a fur door, and when they flip that over, you'll see we have a speakeasy on the back side. Again, front side panel, back side panel, and this is actually a panel within a panel. Okay, the doors we saw earlier being made up, if they are going to be sent out unfinished, they'll be immediately pre-hung, but these particular doors are going to be finished, so they're brought back to our finishing department, where all the glass will be taped off. The squeeze out that we talked about, you'll notice it's not around here anymore because he cut that out. So you cut that out, make it clean for the customer, tape everything off. Then whatever particular color stain, if they want a stain color on, if not, it'll be clear coated, but that particular stain will be put on there. Stain's allowed to dry, and then there'll be multiple coats. It's actually an 8-step process that we do. On the back side here are some jams that have been sprayed. And this one has been sprayed. It's also been clear coated once. And then you have the sanding that's done in between so that you get that nice smooth finish. And then they're going to put another coat on top of here yet. We can step over to the booth and we can actually take a peek inside. They're doing some spraying right now. We like to keep only one person at a time in the spray booth because with more feet walking around, you're going to kick dirt up, and we don't like that. We want to keep those units as clean as possible. Clear coat's going on very milky. That's intentional, and that'll dry very, very clear. That also helps him see what he has coated, what he has not. So he's going to coat that on all sides. It's also important to know that when you have a door unit that's clear coated and stained and finished by a manufacturer, they're going to do under the locks, they're going to do under the hardware, they're going to do under the hinges, and it's actually going to be sealed on all 6 sides, which is something that doesn't often happen when it's actually finished in the field. You may have seen this as a display of ours for a bifold door as well as a screen system. You may have seen this at the International Builder Show in Las Vegas. You also may have seen it at the show at the Farm Show building in Harrisburg. I just kind of want to demonstrate it for you now. This will act as a single door. You can go through this back and forth, in and out with no problem. You don't have to open all the doors, but if you would like to open the doors, you simply come over, pull the top and the bottom pins, give it a push. Everything slides back very, very gently. It's very, very easy to operate. Now, you got this big open area, but you also got bugs. What do you do about that? Pull your screen across. You can do these screens up to 24 feet. And everybody's had that friend who has maybe had one too many and walked into the screen door, knocked it out. Take a look at this system. Somebody would walk into it, it pops out. You got the cracks in the top and the bottom. What do you do to fix it? You simply pull it open, pull it closed, and it has reset. It's a very, very clean system. Cost of this would run you roughly $1,000 to $1,200 a linear foot, depending on how big the opening is. Again, we can do up to 52 feet wide, up to 13 feet tall, but a pretty neat system. And if you walk around behind, I can actually show you the other side where we do have blinds between the glass. So we'll bring this through. If you would want, you have an area, maybe it's overlooking the ocean or overlooking the bay, and sometimes in the evening it might get a little bright. If you want to see it during the day, you can have it wide open. Simply drop it anywhere you want, and you can tilt, turn. So if you wanted the privacy, or if you wanted to be able to block, the harsh sun coming in the evening. Now that our door's been finished and clear coated, the final stages would be to put any hardware in it, which is get some multi-point hardware. So we slide in that body piece in. You're going to put the screws in, and then also over here we have another individual who's then very carefully removing any kind of mask that we would have used to keep that glass clean. On the back side, this is going to be a double. On the back side, we have the door prepped. It's got the hinges already on it. We use ball bearing for everything. Don't do anything less than ball bearing. This has a particular escutcheon on it the customer chose. This is a multi-point, so that when they go to lock the door, they simply lock up on the door, lift up on the handle. It engages the multi-point hooks. We do like to use the ones with the hooks because it does go in behind a jam plate, so you can't even pry this door. And it's very simple, clean to operate. What we're doing here is we're installing the stop mold for the backside panel, and we're also going to install the glass molding for the other side of this. This unit also gets on top of the glass this wrought iron grate. This is an iron grate. This will actually get fixed permanently. I can tell by the holes. But if they wanted it to open and operate, we would weld barrel hinges on it. But you'll notice everything is very, very smooth, and that's because it's cut out of a piece of flat steel. There's no welds that can rust. It's really, really clean. Heavy, but clean. And pretty much you can do any kind of detail you would want with that. If you can come up with the idea, you can come up with the design, we can do it. Okay, what we're doing here on the pre-hang table is we're taking and putting the side lights and door jambs together. Everything's ready to receive the side lights as well as receive the doors. You got the hinges that have been prepped for. You'll also notice that the hinges are finished underneath, so that way you get your best protection from any kind of weather and moisture specifically. In between here, this particular unit is a hurricane rated unit, and it gets a bead of steel in there just to give it that extra rigidity. Other thing we do is we always use a continuous head. We like to use a continuous sill as well. It gives you good strength and durability in a unit. I mentioned earlier, I can jump over here, about those plates that whenever we throw that lock, that's a pretty decent sized plate in there, and it's able to withstand the Force 5 hurricane that's needed. So that piece goes in there, hooks up in behind there so that that door can't be pried. And you'll see this one has a 3-point on it. Some of the doors we go up to, if we're doing a 14-foot tall door, it might have a 7-point lock on it. Again, the finish, nice clean finish, absolutely furniture grade. At this point is where we will also put the coin. So on the edge here, there's a spot where that coin will go. And we don't put that on until pretty much the last thing that we're doing. And again, that coin has that individual serial number. So this will get a hurricane coin to it. That'll go right in that area. And again, that coin has an individual serial number in it. So it will be a one of a kind. It will be for that specific customer. Anything that would be needed to be repaired, or should anything happen down the road, we can get them replacement parts and pieces if a piece of weather strip would wear out, anything of that nature. After a door is pre-hung, or if a door is going to be sent out in slab form for a customer to use in a current opening, the door will be put into a skid, prepped so that it's always standing, either laying down or standing up, but we don't want to ever lay them flat. That can cause potential, especially if there's glass in it, to break. Some of the more popular designs that we see coming up, here's a V-groove plank door. This is crated, and it'll actually be boxed all the way around. This one's going to be leaving the country. And on the other side, you'll see there's one with a piece of glass in it. And it's also got a piece of aluminum on the bottom. For whatever reason, the customer wanted it that way. And finally, you'll see there's one that's skidded up, ready to go on a shrink wrap machine. This will be final inspected. It'll be shrink wrapped. Trucking company will be called. It'll leave here and enjoy a new home. On behalf of all the employees and myself here at Signature Door, thank you very much for taking the time to watch our tour today. We hope you enjoyed it as much as we do producing these products. If you're ever in the Altoona area, please feel free to give us a call, stop in. You can take the tour personally yourself. You can see us at signaturedoor.com. You can see us at facebook.com/Signature Door. And we want to thank PCN for also taking the time to let us show you what we do right here in Altoona. Thank you.